Hi everyone, Miss Negron here. Today we're going to be discussing rotations on a figure in geometry. A rotation is when we turn a figure counterclockwise to the left or clockwise to the right. When looking at a coordinate grid, we need to remember that the axes are perpendicular, forming a right angle. The direction is based on how our quadrants are set up. So in the very first quadrant, which is in the top right-hand corner, moving from first to second quadrant, we are moving to the left. So when we are rotating an image, going counterclockwise, turning the image to the left, will actually give us a positive degree measurement. Starting at the x-axis will represent 0 degrees. Moving once to the left is 90 degrees, twice is 180 degrees, 3 times 270 degrees, and 4 times is 360 degrees, or back to the original. When rotating an image clockwise, we are turning the image to the right, which will represent a negative degree measurement. So starting again at 0 degrees, moving to the right, negative 90 degrees, which is equivalent to a rotation of 270 degrees. 2 rotations to the right is rotation of negative 180 degrees, also the same as a rotation of positive 180. 3 times is a rotation of negative 270, which is the same as a rotation of positive 90. And then 4 times is a rotation of negative 360, which is the same as a rotation of 0 or 360 degrees. The notation for a rotation is a capital letter R with the degree measurement in the subscript. This is extremely important because a lowercase letter r will be used to represent a reflection, which will be discussed in another video. Distance, which is the length of the sides, and angle measure are preserved after a rotation. Therefore, the pre and prime images are congruent. Orientation is also preserved, as the relative position of the points and the order in which you read them stay the same. Because the pre and prime images are congruent, a rotation is also known as a rigid motion or an isometry. Similarly, a translation, which was discussed in another video, is also a rigid motion, and reflections and glide reflections are considered rigid motions as well. So let's try some practice. If we were graphing a rotation centered at the origin on a coordinate grid, you are going to turn the image similarly to the previous slide. So if we were rotating 90 degrees, we are going to turn our image once to the left, and now read our coordinate points as if the axes flipped. So A prime would be negative 1, 7, B prime negative 4, 6, and C prime negative 2, 3. Based on this rotation, you will see that the coordinates have flipped and the y negated. Rotating your image now 180 degrees is 2 times to the left. So similarly to what we just did, we now read our coordinate points as if our axes changed. So A prime would be negative 7, negative 1, B prime would be negative 6, negative 4, and C prime would be negative 3, negative 2, showing us that after a rotation of 180, the coordinate points negate, which means their signs change. Lastly, for a rotation of 270 degrees, A prime would become 1, negative 7, B prime 4, negative 6, and C prime 2, negative 3, showing us that after a rotation of 270, our coordinate points flip and the x-coordinate negates. Rotating back for a full 360 will give us our original image. Now let's graph a rotation of 90 degrees centered at the origin. So if we were to rotate it, which is what we just discussed, the coordinate points would flip and the y values would negate. If we were to graph this and see both images side by side, you would have A, B, and C, your original image in the first quadrant, and triangle ABC prime in the second. Now let's take a look at rotations centered at a point other than the origin. For this example, we are going to rotate triangle ABC negative 90 degrees centered at the point P, which is negative 3, 4. So the first thing you want to do is translate your center point to the origin and then perform the same translation on your image. Because here your point P is negative 3, 4, the translation moving it back to the origin would be a translation of 3 units right and 4 units down. So in this case, A would move to 10, negative 3, B, 9, 0, and C, 6, negative 2. Now you're going to rotate that figure, in this specific case, once to the right, which is negative 90 degrees, or a rotation of 270, which is 3 times to the left. Based on our previous discussion, a rotation of negative 90 will yield you flipped coordinates and your x-coordinate will negate. So in this specific case, A would move from 10, negative 3 to negative 3, negative 10. B would become 0, negative 9, and C would become negative 2, negative 6. Our last step here is to undo the original translation. So because our original translation was 3 units to the right and 4 units down, we are now going to move the image 3 units left and 4 units up. This will now give us our new coordinate points of A prime being negative 6, negative 6, B prime being negative 3, negative 5, and C prime negative 5, 2. Here would be the image of both our original and prime image on the graph. For more videos, please check out transformations, including translations, reflections, dilations, composition of transformations, dilations on a linear equation, partitioning, and area of a figure on a coordinate grid. Thank you for watching and stay tuned for more videos.